So, and next one is ALL, acute lymphoblastic leukemia. And the thing I want you to remember, every time you mention ALL, you should also add lymphoblastic lymphoma because it's a spectrum of the same disease. Biologically, it's the same malignancy, only it's a different stage. And basically, without treatment, if it's lymphoblastic lymphoma, either T or B, at the end, it will progress into acute lymphoblastic leukemia. Now, what's the difference? The only difference is the amount of blasts in the bone marrow. So in case there is more than 25% of blasts, either T or B, doesn't matter, or T or B precursors, then it's called leukemia. If it's still below 25% and you got extranodal masses or nodal masses or mediastinal masses, then you call it lymphoblastic lymphoma. And in terms of T cells, T lymphoblastic lymphoma, the mediastinum is crucial. That's a hallmark. Typically, it starts over there, but there could be some extranodal locations as well. It could be in the skin, in bone, in metaphysis, or wherever, and also CNS. Okay. In terms of B lymphoblastic lymphoma, interestingly enough, more commonly the masses are formed extranodally, like again in skin and other organs, in the neck area as well, but also in mediastinum, which is of course much less common than in T lymphoblastic lymphoma, but you can see it, and also CNS again. So don't forget these locations. And want to stress again that it's the same disease. I'm going to use the term ALL, that you all are aware of that, but still remember to add lymphoblastic lymphoma because it's one disease. It's a different stage of one disease. And again, I want to stress the untreated lymphoblastic lymphoma will turn sooner or later into acute lymphoblastic leukemia because the amount of the blast will go over the 25%. And that's it. So you're treating it just the same way as a acute lymphoblastic leukemia, although still the amount of blast is not as high. Okay, so the treatment is the same. So cell of origin, let's go through it. It's lymphoid progenitor, and typically it's again whether it's progenitor B cell or precursor B cell or progenitor T cells or precursor T cells. Okay, the mutation happens in lymphoid progenitor, but again, it's a bit later in the tree. So those are progenitor B or T or precursor B or T, okay, or T cells. Happens in early lymphopoiesis. It's before they encounter a antigen. So early lymphopoiesis. Yeah. What about the primary physiological process affected? Over here, it's the VDJ recombination. That's VDJ recombination transcriptor factor dysregulation. So VDJ is crucial. Transcription factor dysregulation. Timing of oncogenic events, typically it's prenatal. It happens prenatally. Okay, so prenatal or very near the birth. Okay, so it's prenatal or early postnatal. Okay. Mechanism of transformation, developmental arrest at lymphoblast. Okay, so arrest at lymphoblast. So they're not maturing. Common driving mutations. Typically, again, ETV, RANX1, BCR-ABL as well. Don't forget that. BCR-ABL, that's the Philadelphia chromosome positive ALL. And that's enough, let's say. The next role of viral infections, no, there's another direct connection with viral infections. This is a contrast to classic lymphomas. That's very obvious. There is a connection to infections, viral infections, etc. Not in case of acute lymphoblastic leukemia. Common age, here are children, so remember children. Typically BALL. If you're in adolescence, that's rather T cell. So TLL. Teenagers, remember I told you that. Adolescents. Then primary site of disease, It's either bone marrow or, remember, thymus, as we talked about. So bone marrow, thymus. Okay, remember that. And if I want to be more specific, for the B, acute lymphoblastic leukemia, it's bone marrow. But for the T, for the T, acute lymphoblastic leukemia, it could be either bone marrow or thymus. Yeah, thymus, again, I'm stressing the teenagers. That's typical. Okay. Immunophenotyping, so those are typically CD19 positive, CD10 positive, TDT positive. Okay, let's pick a few of them. Is there a somatic hypermutation in the game? No, it isn't. Is there VDJ? It's a common source of translocation, so that's a common source of translocation. So in TAL1 and other ones. Clinical behavior, it's aggressive, but it's curable. Okay, it's curable. So in children, it's aggressive, but curable. Although afterwards they can have other cancers. Okay, unfortunately, thanks to chemotherapy, but yeah, it's curable. And how is it with the transplantation? It is allogenic hematopoietic stem cell transplantation in high risk or relapse ALL. Okay, so allogenic hematopoietic stem cell transplantation. That was acute lymphoblastic leukemia, and let's get to lymphomas. And that's different, lymphomas, because over here those are mature cells. That's crucial. So what color we're going to put? Let's put a green one. So green. So in B-cell lymphomas, it's a mature B cells. So post, pre, germinal center, memory, B, marginal zone. So remember these lymphomas. Developmental stage, it's around germinal center. So it's somewhere around the activation of antigen. So around the germinal center, and it's around the activation of antigen. Okay, and what is the primary physiological process affected? Well, that's somatic hypermutation and class switch recombination. Although these processes are distinct, they are related because they are AID dependent. So, and this means, again, the more infections I have, the higher probability that something will go wrong and a lymphoma will develop. I'll still mention it in a sec. And now, timing of oncogenic events. So it's post or around the antigenic stimulation or chronic inflammation. So antigenic stimulation, chronic inflammation. Well, that's the same. Yeah, and what's the mechanism of transformation? Well, it's the dysregulated clonal expansion, which is connected with the AID-mediated mutation. So AID, that's the activation-induced cytidine deaminase, and that's crucial for both for somatic hypermutation and class switch recombination. Okay, so this is crucial, and this is the point where it happens. Okay, so these mutations. So, and these cells escape the, let's say, selection in lymph nodes and wherever, and start to proliferate. So let's put the mechanisms. That's the dysregulated clonal expansion in AID. So again, activation-induced cytidine deaminase mediated mutations. And again, it's somatic hypermutation and class switch recombination is responsible for both of these. So common driver mutations, typically those are the translocations. So again, T14 to 18, and MYC mutation, BCL6, and many other. Okay, next, is there a role of infection? Definitely, 100%. We talked about Epstein-Barr virus, so EBV. We talked about HIV, of course. You can still put over here hepatitis C virus, so HCV. And also you can put the human herpes virus 8, so HHV8, very commonly associated. What is the common age? Adults. You should imagine adults. Adults, obviously. The longer you live, more infections you have, the more probable lymphomas will appear. It's over 40 years. 40 years. Mainly, it varies, but over 40 years, it's typical. Primary site of disease, lymph nodes, spleen, mucosal sites, as we talked about MALT. Okay, so lymph nodes, spleen, MALT, so mucosa associated, and of course also doesn't have to be mucosa like in Hashimoto's, and we talked about it, so in the thyroid gland. Immunophenotype. Immunophenotype CD20, typically CD20 positive, CD10 positive. Yeah, we can leave this. Somatic hypermutation. Yes, we talked about it. Of course, that's crucial. So yes, it's AID, see activation-induced cytidine deaminase dependent. So AID enzyme makes a mess over there, so it's dependent. Hypermutations, everything. It's germinal center based. And what about the VDJ recombination? Well, it's not the mechanism, okay, because this is about mature cells, and the VDJ recombination is about immature cells. Okay, so remember that it's not the mechanism. What is the clinical behavior? They're typically indolent in cases of follicular lymphoma. So some of them are indolent. That's follicular lymphoma and marginal zone. So follicular lymphoma, marginal zone lymphoma. Or it could be aggressive, that we talked about it again. So that's Burkitt or TLBCL. That's typical. Well, and over here, that's the difference. Over here, primarily you use autologous because the stem cells are okay. Mutation happens in the mature cells, in the autologous hematopoietic stem cell transplantation. Okay. It's used in the aggressive lymphomas. Okay, in aggressive, especially in aggressive lymphomas. Okay. Okay, and let's get to the last one. So that's the T-cell lymphoma. And what color should I pick? Which one? So put the red one now. Okay, so of course we're talking about in terms of cell of origin with mature T cells. So mature T cells. What is the developmental stage? That's the post-thymic antigen experienced T cells. So those are post-thymic antigen experienced T cells. In case these would not be experienced, would be immature, that would be acute lymphoblastic leukemia, T acute lymphoblastic leukemia / lymphoma, or lymphoblastic lymphoma, T lymphoblastic lymphoma. Just want to stress this. If it's mature, it's classical T lymphoma. Okay. What is the primary physiological process affected? That's the TCR signaling. So that's the TCR signaling. It's about cytokines, response, apoptosis, regulation, epigenetic remodeling. Okay. So let's put one here, cytokine response. Cytokine response. What about timing of oncogenic events? Well, over here, that's typical post-thymic, again, in peripheral T cells, often under chronic immune stimulation. So again, the role of the chronic stimulation is crucial. So post-thymic, again, and peripheral T cells. What about the mechanisms of transformation? That's a TCR cytokine-driven proliferation. It's a epigenetic drift immune escape. So TCR cytokine-driven proliferation. Okay. What's the common driver mutation or translocation? It's the, again, TET2, could be TET2, and some fusions, or over here with RHOA. So I can mention it here, RHOA. You don't have to know this at all, G17V. Role of viral infection, that's so very common in ATL, of course. We talked about it. So ATLL, so over here it's the human T lymphotropic virus type 1. That's typical, so HTLV1, crucial. Don't forget, sometimes it could be EB virus as well. So EB virus, okay? What about the common age group? So typically adults, middle-aged to elderly. So adults, let's put adults. Adults or middle-aged. Primary site of disease, lymph nodes, of course. Lymph nodes, spleen, liver, systemic involvement. Don't forget the skin. Okay, so lymph nodes, again, lymph nodes, spleen, liver, skin. Immunophenotyping, so it's CD3 positive, CD3 plus, 4 plus, and many other. Somatic hypermutation, it's absent because we don't have it in T cells, so they don't undergo the somatic hypermutation. So no, it's absent. And what about the VDJ recombination errors? Well, these are mature T-cell lymphomas, or these are lymphomas from mature T cells where the VDJ recombination is already absent, so the errors cannot happen in this mechanism. So this mechanism, again, it's not the mechanism. Okay, so let's cross it out. The next is clinical behavior. So what about so clinical behavior. Indolent in, as we said, in Sézary syndrome, or in mycosis fungoides or Sézary syndrome. Aggressive, typically in the adult T-cell leukemia, so in the ATLL. And how is it with treatment? So those are lymphomas, T lymphomas. So autologous hematopoietic stem cell transplantation. In some relapses, in some cases, it's allogeneic. You use allogeneic and refractory and whatever. So yeah, of course, in both you can allogeneic in refractory cases. That's the same with the B lymphomas as well. In case they're refractory, in selected cases, you do a allogenic transplantation. I could still put in here. So in refractory and specific cases, you do allogenic. But you always try, in both lymphomas, B or T, you always try first to do autologous hematopoietic stem cell transplantation. Well, that's it. That's the whole table. There are so many things, but you can really see the patterns, which is if it's virus related, like chronic infection related, where it happens, if it's in a stem cell, early in stem cell, or in some progenitors. Interesting thing you should remember is if it's acute lymphoblastic leukemia or acute myelogenous leukemia, they will rather, if something happens more, they will stay within the lineage, okay? In contrast to myelodysplastic syndrome and myeloproliferative neoplasm, which can also transform, not as commonly, but they can transform into lymphoblastic leukemia, acute lymphoblastic leukemia. And especially, again, I'm stressing the transplantation treatment, where obviously in all the myeloid neoplasms, you do allogenic transplantation. Also in the lymphoblastic leukemia, you very rarely can try autologous transplantation, but in lymphomas, if they're aggressive, it's typical when you use autologous hematopoietic stem cell transplantation. Remember that. So that's the whole table. So let's get to the next point.
So, thanks for watching, and don't forget to subscribe and ring that bell. And as always, check the description below for supplementary questions and other materials.